Good day, everyone. I am Ivan Larazabal alongside my teammates Prince Segovia and Kyle Corbingo, and we are Team Manong Gab. Today, we'll be discussing universal hashing. Universal hashing is a technique used in computer science and information theory to design better hash functions. Instead of using just one fixed hash function, universal hashing uses a family of hash functions and randomly selects one. The main purpose of universal hashing is to reduce collisions, which happen when different keys produce the same hash value. By minimizing collisions, hash table operations like searching, inserting, and deleting becomes more efficient and reliable.
So the key concepts of universal hashing and its advantages and disadvantages. For its advantages, it lowers the possibility of collisions by offering a high degree of unpredictability in the choice of hash functions, and it can be utilized in many different applications and is easy to implement because of its great degree of versatility in the family of hash functions. It can be easily modified to maximize speed for particular datasets. And as for its disadvantages, uh, creating a large number of hash functions can be computationally expensive, and the hash functions must be carefully chosen to preserve their independence, and it may not be appropriate for all datasets, especially those with complex or unpredictable distributions. How it works. So, number one, that it creates a family of hash functions. A universal family, H, is a set of hash functions. For any two distinct keys, the probability of them colliding is at most 1 over m, where m is the number of available hash buckets of the slots. When the program starts, randomly select 1 at the start of the operation. The application randomly selects one hash function, and this function is then used for all hashing operations, which is insert, search, and delete until a performance issue necessitates picking a random function and rehashing the entire table. All keys are hashed by applying the function. When a key k needs to be stored or retrieved, the selected function is applied to it, resulting in a hash value or index within the table. Collision resolution. Collisions still happen in certain cases, but the universal family ensures that they are all uniformly distributed. On average, techniques like separate chain or open addressing are used to handle these collisions efficiently.
And building a universal hash family utilizes as a matrix approach where the table is at size m is a power of 2 and key are u bits long and index represented with b bits, where m equals 2b, a random b by u binary matrix. H is chosen, and hash function h and x is defined as hx, computed by adding selected columns of an h base on the 1 bits in the key x. The matrices used in this method are characterized as fat and short. Thank you.
To conclude, universal hashing helps improve the performance of hash tables by reducing the probability of collisions between different keys. By randomly choosing a hash function from a family of hash functions, it prevents predictable patterns and avoid worst-case scenarios. Because of this, universal hashing is an effective and reliable technique in designing efficient data structures. That's all, and thank you for listening.